the third unit of our course, we look at regression models. These are models where we are looking at a relationship between two different numerical quantities. So for example, we might say, is there a connection between the number of hours of sleep a person gets and that person's grade on a knowledge festival? A timely example: to what extent does a community's infection rate or disease rate with COVID, is that connected to its population density? Maybe more densely populated areas have higher rates of transmission. Somewhat tongue-in-cheek, stock market returns and sunspots. Is there a connection? Notice that not all relationships are regression relationships. In particular, regression looks at one numerical variable related to another numerical variable. And so if we're trying to connect amount of sleep, and that's a number of hours of sleep, with grade, but we express grade as ABCDF, ABCDF is not a number. We're not in regression world. We would need to know a numerical grade for it to be regression. This is an intro stats class. We're going to keep things simple, the relationship between a numerical variable and a numerical variable. What if it ain't? Good question. That's for your upper level statistics and analytics electives. Some basic vocabulary and some basic concepts. We're looking at a relationship between two quantities, and usually, not always, but usually we can envision one of them as causing or deriving or influencing the other one. And so, for example, maybe the amount of sleep that you get influences your grade on the knowledge festival. Sleep here is our cause-er variable. In technical terms, it's called the independent variable. And we use the letter X typically to symbolize it. Sleep is the cause-er, the outcome, the cause-e, the result is your grade. The dependent variable, more formally, because it depends upon the independent variable. Usually the letter Y is used to indicate the dependent variable. And so let's make sure we've got these concepts down here. Our second example was to the extent to which a community's infection rate with COVID depends upon or is influenced by its population density. So I'm going to ask you to pause the video here, take some time, answer those 4 questions, then unpause the video. Okay. Virus infection rate is one of our variables. Population density is the other. And those are both numbers, so we're doing a regression model here. Density is the independent variable, the X variable. We think the extent to which people are clustered or packed together or congregated might influence the disease spread. Whereas infection rate is the dependent variable. We think it may depend upon how many other folk are around. It's the Y variable. Let's take a look at another example just to illustrate here. And again, simple example, We're looking at the influence of sleep upon knowledge festival grade. And I grabbed data on 42 students, 42 of my imaginary friends. And here are those data. We will, of course, draw a picture. Always draw a picture. Sleep is the X variable, the independent variable. We think grade depends upon or might be influenced by sleep. So sleep goes on the horizontal axis, grade goes on the vertical axis. Where were Alfonso and Balf on this graph? You'll recall Alfonso had 6.5 hours of sleep, 82. Balf had no sleep, shame on him, and a 26. So where are they on the graph? Alfonso's here, 6.5 hours of sleep, 82. Balf's here, no sleep, 26. And in general, for our 42 imaginary friends, the data tend to cluster along this southwest to northeast line. It's a general upward tendency. Folk who get more sleep tend to have higher grades, although there are exceptions. The relation's no means perfect. We can even envision a line running through the middle of the data. That line is called the regression line. It's in red here. Another issue to be aware of is how closely the data are concentrated around the line. Two different classes here. We're still looking at the relationship between sleep and grade, and in this class, that connection is pretty tight. Where in this class, that connection is much more diffuse. The two classes have pretty much the same regression line, the same line running through the middle of things, but there's a lot more spread outness in the second one than the first one. The strength of relationship is something we call the correlation. So, quick summary here. We're looking at a relationship between two numerical quantities. A cause an independent variable, an X variable, and a cause E, an outcome, a dependent variable, the letter Y. The line running through the middle of those data is the regression line. Correlation tells us how closely those two things are related. And in subsequent videos, we'll look at computing these quantities.